Hi everyone. Hey, see some of you already there. Fantastic. Okay, so we're going to do a little bit of a recap of some of the things we talked about last time and then extend a little bit, talk a little bit more about estimating. Fantastic. Excellent. So let's get started. So we talked last time about how you can round to a number of decimal places or to a number of significant figures. So some of you might not be familiar with both of these, or even either of them. Um, Another way of rounding numbers is to round to the nearest whole number, or to the nearest 10, or to the nearest 100. Rounding's really important because we don't really want to have to say a whole number like this, 26.227, if we're giving a piece of information to someone. It's nice to be able to round our final answers in a calculation as well. But we should only round at the end of a calculation or if we need to for the method that we're using. So we have to make sure we're not rounding all the time. If we round too often, then we really do reduce our accuracy, the accuracy of our work that we're doing. So here are a couple of different ways we can round. So first of all, to decimal places. So for this column, I'm going to round all of these numbers to 2 decimal places, and you can have a go along with me if you like. So to round a number to 2 decimal places, I need to look for where the decimal point is. Then I look for my first decimal place, which is the number straight to the right of the decimal point. And then the second decimal place is the number directly to the right of that. Okay, so they're my first and second decimal place. That's going to be the end of my number once it's rounded. It's only going to have those 2 decimal digits. But I need to look at this next digit, which is called the decider, to tell me whether I need to round my 8, the second decimal digit, up or not. So if this number was a 5 or bigger, then I would round the 8 up to a 9, because my number would be closer to 0.39 than it is to 0.38. But because the numbers are 4, I'm going to round down. And the way we round down is just by cutting the end off the number. That's all we need to do. We don't need to change anything else. So to 2 decimal places, this number is going to be 0.38. Okay, so what about the next one? Decimal point, first decimal place, second decimal place. So that's going to be the end of our number. And this is the decider. So this tells me whether I need to round the 1 up or not. And it's a 2, it's lower than a 5, so I don't need to round it up. So my number to 2 decimal places is 163.21. So hopefully you're following along with this and it's making some sense. Sometimes if you come back to something later on, keep coming back to it, it starts to make a little bit more sense. And other times it can be good to leave it, learn a bit more about other areas of maths, and then come back to it again. And sometimes that all just helps to keep improving our knowledge and learning more and more about maths. So the next one, first decimal digit, second decimal digit. That's going to be our decider. And again, our decider is quite low, so we don't need to round our number up. We just cut the end off, basically. 93.95. So I bet you're getting to the point where you can do these pretty well yourselves now. So first, second, this is the decider. It's a 5, so we need to round up. 2.95. First decimal digit, second decimal digit, that's the decider. It's bigger than a 5, so we need to round up. 26.23. And the last one, first and second decimal digit, and then the 7 is the decider. 7's bigger than a 5, so we're going to round up, so we get 0.06. Brilliant. All right, what about significant figures? I'm going to do a bit of rubbing out so we can see more clearly. Significant figures are just a different way of rounding. And in some ways, they make a little bit more sense because depending on how many digits and what the values of the digits are in your number, you'll round your number a little bit more, a bit differently. Okay. So the first significant figure is always the first digit that isn't a 0 in your number. So as you go from the left, as though you're reading the number, look for the first digit that isn't a 0. So that's this 3. So that's my first significant figure. The 8 is my second significant figure. So that's where the number's going to end. The 4 is the decider. So just like before, we need to think, is this number 5 or bigger? And it's not. So we don't need to change anything. We just cut the end off, basically. So we get 0.38. And notice it's the same in this case, but it's not always going to be the same. Be interesting to see when our rounding makes our numbers the same to 2 decimal places and 2 significant figures, and when it's different. Brilliant. What about the next one? Ooh, this is a bit different because this is going to be our first significant figure, isn't it? The 1, the 100. This is the second significant figure. So all we're saying is these are the 2 most important numbers, important digits in our number, because they have the biggest value of all the digits. Because this 1 is the number of hundreds, and the 6 is the number of tens, whereas these numbers over here, they're just little fractions, aren't they? Brilliant. So I'm going to draw this line again, but this is going to be slightly different. So let's look at this number as the decider. It's smaller than a 5, so that means we don't round up. So we've got our 1 and our 6, they just stay as they were. But this number 16 is now nothing like the original number 163, is it? So in this case, we have to replace that 3 with a 0. So that means we've rounded, in this case, to the nearest 10, haven't we? But we always need to put some zeros in to preserve the place value whenever that's necessary. You'll particularly notice this if you've got fairly big numbers that you're rounding to significant figures. So hopefully that makes sense. I've put that 0 there in place of the 3 so that the 6 remains 6 tens and the 1 stays as 100. Otherwise, it would be 110 and 6 10. No, yes, 110 and 6 ones. Okay, and that would be completely different, a completely different number, wouldn't it? Brilliant. What about the next one then? So this is the first significant figure and the second. So we're going to use, this is the end of our number, we're going to use this as our decider. It's a 9, it's bigger than a 5 or bigger. So that means we need to round the 3 up to a 4. 94. And that's similar to the number. That looks good. What about the next one? First significant figure, that's going to be the 2. The second significant figure is the 9. So it's the same as the first decimal place, isn't it? We look at the 4 as the decider. That's the one after the second significant figure. And it's less than a 5, isn't it? So that means we don't need to round up. To 2 significant figures, our answer is 2.9. So hopefully this is making a bit more sense. Those of you who were finding it a little bit tricky last time, just because it's something new. Brilliant. All right, next one. First significant figure, second significant figure, then we look for the decider. It's less than a 5, so we don't need to round. Our answer is just going to be 26. And then finally, ooh, this is an interesting one. So this first digit here, it's a 0, isn't it? And so is this second digit. So the first significant figure is actually this 5. The second one is the 7. So the decider is going to be this 8. Okay. The 8 is bigger than a 5, so we need to round the 7 up to an 8. So our number in the end is going to be 0.058. Wow. So in most of these cases, actually, our numbers have ended up being a little bit different depending on whether we've rounded to 2 decimal places or 2 significant figures. The only time they'll really be the same is if the number has the first decimal place and the first significant figure in the same place. So if it's 0 point, then a number starting with a digit that isn't a 0. Yeah, fantastic. Hopefully that's making sense. And do feel free to send across any questions either now or later on that you might have. Brilliant. So rounding's really important. So it's great that we're having a think about that. and some different ways of rounding. Let's have a think about estimation now. So often when we estimate, we think about rounding to one significant figure and then calculating. But actually, you can estimate in lots of different ways. As long as you're doing it in a sensible way, that's fine. And again, another warning, your answer isn't going to be accurate. This is a brilliant method to use if you want to check the answer to a difficult calculation. Or, of course, if you're asked to estimate, if you're asked in a question to estimate an answer, don't work it out fully because that's not what you've been asked to do. So in these questions, I'm asking you to round to one significant figure and then calculate. So let's round these to one significant figure. The first significant figure for this number is the 3. So the 4 is the decider. So we don't need to round the 3 up. It's just going to be a 3, isn't it? The next one, 4.1, the first significant figure is the 4. And the 1, again, it's not a 5 or bigger, so we're just going to round down, keep it as a 4. 3 times 4. And this is an approximately equal to sign. So we're saying this is nearly equal to 3 times 4, and 3 times 4 is 12. So we've made a rough estimate for the answer to our question. Okay, what about this one? 7.9. So to one significant figure, that's going to be 8. 4.2. To one significant figure, that's going to be 4. 8 divided by 4, that gives us 2, right? Fantastic. So this is one way of estimating. So let's have a go at some more difficult estimation questions. Can you round these to one significant figure and then calculate? So 3.4, that's, let's see, approximately equal to. 3.4 is approximately a 3. 9.5, well, that would round to a 10, wouldn't it? 4.2, that would round to a 4. So 3 times 10 times 4. Ooh, how could we work this out? We could do 3 times 4 first. That's 12, and then times our answer by 10. So that's going to be 120, isn't it? Awesome. What about the next one? Let's do exactly the same thing. Let's practice this particular method of rounding to one significant figure. So 9.4, that's going to round to a 9. And then we're going to take away 1.6, so let's round that to a 2. And then let's put the brackets in. And we're going to talk a little bit about big maths next time, which is really important. And then we're going to times that by 7.3 rounded to one significant figure. That's going to be 7. So 9 take away 2. We do that first because it's in brackets. That's 7. Times that by 7. That's going to give us 49. So hopefully this is making sense. This is just a rough answer to our question, but it's going to be a lot easier than working out the actual answer. And if you had to work out the actual answer, you could check that it's approximately 49, just to make sure that your answer's on the right track. What about this one? Ooh, this would take a while to do. 943. So to one significant figure, the first significant figure is the 9. The next digit, the decider, is a 4. So we need to round the whole number down. In other words, just cut off the 4 and 3 and replace them with zeros. So we're doing 900, and then we're going to take away to one significant figure. This one's going to end up being 200. And then we're going to times our answer by 11. Let's round that to 10. Brilliant. So 900 take away 200. That's going to be 700, isn't it? So this is much easier to calculate. And then we're going to times that by 10. So that's going to give us 7,000. Brilliant. Let's do one more, and I bet you can do the last one yourselves. 3.5. So we'd have to round that up, wouldn't we, to a 4. And then we're going to take away 2. So to one significant figure, that's going to be a 2. 4 take away 2. And then we're going to divide by 2. I've rounded that to one significant figure. So that's going to be 4 take away 2. That's just 2 divided by 2. So my answer is going to be 1. Brilliant. All right. Yeah, and I bet you can finish that last one off as well. I mentioned last time, very briefly, that sometimes there are other sensible ways to estimate. It isn't always necessarily a good idea to round to one significant figure. If I'm asked to estimate the square root of 24, if I round it to 20 to one significant figure and try to work out the square root of 20, that's going to be just as hard as the square root of 24, isn't it? So it might be more sensible to round it up slightly to 25, because I know 25 is a square number, so I can find the square root of it a lot more easily. That's going to be 5. So my estimation of the square root of 24, 5 would be a good guess, a good approximation there. Okay. What about this one? Can you think of a way you might estimate a ninth of 55? What would it be sensible to round 55 to? So to one significant figure, 55 would turn into 60, wouldn't it? But a ninth of 60 is probably not that much easier than a ninth of 55. So how about I round it to 54? Because 54 is in the 9 times table, so I can easily divide it by 9 to find a ninth. Does that make sense? So 54 divided by 9, that would give me 6. So I've got a rough idea of what a ninth of 55 will be, but I didn't round in the same way as I was showing you. So bear in mind that depending on your question, you might want to round or change your number slightly differently. This one, square root of 124. Can you think of a number near to 124 that you know the square root of? That you know the number you would times by itself to make that number? So what about 121? That's the one that popped into my head. Square root of 121 is 11, isn't it? So this is going to be approximately 11, the square root of 124. And the cube root of 9, that would look like this. So the cube root is basically the number you would cube, you would times by itself and then times by itself again to make 9. And again, we'll talk about this a little bit more next week, actually. So what might we want to round that to? So I know the cube root of 8. I know a number that I would times by itself and then times by itself again to make 8. That's going to be 2. So the cube root of 9 is approximately the cube root of 8, which is 2. So different ways of estimating. And finally, let's do a little bit of a recap again about upper and lower bounds. And I just want to reiterate, it doesn't matter if you're finding this tricky at the beginning, because I know a lot of you won't have heard much about this before. But it's interesting to think about. And you could come across questions like these ones that maybe don't mention upper and lower bounds, but you use the same sorts of ideas that we're talking about. Okay, so a book has a length of 10 centimetres to the nearest centimetre. What's the shortest the book could be? Okay, so I need to think when this book was first measured, before the length was rounded to the nearest centimetre, what are the possibilities of the length it may have had? So it could have been quite a bit shorter than 10 centimetres, couldn't it? And it would have been rounded up to 10 centimetres when it was rounded. So it could actually have been 9.5 centimetres, half of a centimetre smaller than 10 centimetres, and it would still have rounded up. So hopefully that makes a bit of sense, and this is called the lower bound for the length of the book. When you're thinking about the upper bound, the longest the book might have been, it's a little bit trickier in a way, because it could have been almost half a centimetre above 10 centimetres, so 10.5 centimetres, but not quite, because if it was 10.5 centimetres, it would have rounded up to 11 centimetres, wouldn't it? So it would have to be a teeny, teeny, tiny bit less, a teeny, tiny bit shorter than 10.5 centimetres. And that's the longest that the book could be. So often we'll write the upper bound, the tallest or the longest that something could be, um, as a slightly bigger number than it really should be, just to make it a little bit easier. Yeah. So what about this one? James is 180 centimeters tall to the nearest centimeter. What's the tallest he could be? So we need to think about what the tallest is that he could have been measured as, and it still have rounded down to 180. If we use the same sort of idea and think about half a unit up and half a unit down from this number we've rounded to. So we're rounding to the nearest centimetre. That means it could have been half a centimetre. He could have been half a centimetre smaller. That would have rounded up. And he could have been almost half a centimetre taller. Almost. So the tallest he could be is almost 180.5. Technically, that's not quite right. He would have rounded up, wouldn't he, to 181 centimetres, because this decider would be a 5. But you could say his height is something less than 180.5. Okay, and it could just be a teeny tiny bit less, but it's something a little bit less, at least, than 180.5. So hopefully that makes a little bit of sense. Brilliant. So we can use these signs, inequality signs, to help us to be able to express this a bit better. But otherwise, you would just say the upper bound is 180.5. So that's the top boundary for his height. So let's have a go at doing something similar with these sorts of questions. I know these might be a little bit trickier because they're a bit more abstract. We've not got a scenario attached to them. Once we work out the upper bound and the lower bound, like I said before, we could use inequality signs to help us to express it a little bit better. And this is called an error interval. So 250, if it's rounded to two significant figures, that means the last digit would have been a 10, right? So, well, the digit it was rounded to would have been a 10. So that means we could be half of 10 below or half of 10 above, and it would still have just about rounded to 250. So the upper bound is going to be 255, and the lower bound is going to be 245. So notice I've taken 5 off, half of 10 in the column we've rounded to, and I've added 5 as well. If you look at the lower bound, you should see that if you round it to two significant figures, you end up with this answer. It's the lowest number that you could round to two significant figures, and it would be 250. But this one here, you should see, if you round it to two significant figures, it's the lowest number that would actually round up to the next digit, the next number, the next value. It would actually round up to 260. But that's okay. That's actually totally normal. Once we put them here in this inequality sign, it will start to make a bit more sense. Because if I put the lower bound here, 245, and the upper bound here, let's read what it says. It says that 245 is less than or equal to x. So let's call my number x. So x could be equal to or greater than 245. And 255 is greater than x. Okay? It can't be equal to 255 though, can it? And we already said that, because if it was equal to 255, it would round up. It would round up to 260. So hopefully that clarifies that a little bit. And hey, really well done if you're thinking about these ideas. Fantastic. Let's have a go with these questions as well. Let's see if we can write some error intervals for them too. So if this is rounded to 2 decimal places, so this is the last digit, second decimal place. So the upper bound is going to be half of the value of this column above our number. So it's going to be 3.045. The lower bound is going to be half of this, the value of this column below our number, 3.035, right? When you have a think about it, try and round this number to 2 decimal places. You should end up with the number you started with when you do that with the lower bound. But when you do it with the upper bound, you should find you only just end up rounding it up to the next number. If you took even a tiny bit off this, it would end up rounding down because it's the upper bound. And let's just call this y, just for the sake of argument, and let's write an error interval for y. And I know this looks a bit complicated, but we know what it means, don't we? We know it's not actually as complicated as it looks. We need to put the lower bound here, so that's going to be 3.035, and the upper bound goes here, 3.045. So we're saying one way to express something like this is to say y is in between 3.035 and 3.045. But then you have to also remember it could be equal to 3.035, but it can't be equal to 3.045. And that's exactly what we've been saying about these upper and lower bounds. This is a really nice way to express them, and it's called an error interval. Let's do one more. Let's do this one. So 900 rounded to one significant figure. We rounded it to one significant figure. So this is the digit that we rounded to. That means our upper bound's going to be half of one of these units. So half of 100 above. So in other words, 50 above, 950. And our lower bound is going to be 50 below, half of one of these units below. So 850. So let's do an error interval again. So we're going to put Z in the middle. We're saying that Z is in between. We need to make sure we always put the lower number here with the smaller part, the closed part of our inequality sign pointing to it. And then the bigger one goes on that side. Z is in between 850 and 950. And it could be equal to 850, but it can't be equal to 950. It has to be a tiny bit underneath, below 950. Otherwise, it would round up to 1,000. Fantastic, brilliant. Okay, and here we've just really done this, haven't we? Here we've got a couple more error intervals that maybe we'll do a little quick review of this next time. There are some extra practice questions here that you could have a go at, including some that have error intervals and upper and lower bounds. So have a go at those because there are answers on the worksheet for these. And then if you're feeling confident, you could have a go at those couple of questions that we missed out. Yeah, and see what you think. And then finally, a bit of estimation as well. So have a go at some of those too. And hey, I'm super impressed with the work that we're looking at the moment. This is some tricky stuff. Really, really well done. I'll see you next time. And next time we'll be thinking about, we'll do a little bit of an overview, but we'll also be thinking about some powers, some laws of indices, which is kind of interesting, and a little bit of BIDMAS as well. So fantastic. And you're very welcome, people saying thank you for the lesson. I'll really look forward to seeing you next time. And thank you for joining me. That was brilliant. Very well done. And I will see you very soon. Bye, everyone.